Dielectric constant is also known as the relative permittivity of medium. Relative permittivity. And I will represent this with capital K, and this capital K is the ratio of permittivity of medium divided by permittivity of free space, or you can say air, and this is also represented by force of two charges when you will place in air, and force in two charges when you will place in those charges in medium. So we are studying the dielectric constant. We know that we have this formula when two charges, suppose you have two charges, Q1 and Q2. These two charges are point charges and they are separated by a distance r,
Yes, sir.
and they are in some medium. Medium means other than air can also be the medium, but I am just saying here, I am not talking about the air. I am just talking the medium can be air, the medium can be water, the medium can be gas, a general medium you can say. And this
Okay, sir.
medium have the permittivity, this epsilon suffix m. I have discussed here also. You can see here. This. When we have placed this system in some medium, like air, water, and oil can be the medium, and that time we have calculated the force in this way. We have this 1/4 pi epsilon suffix m, permittivity of medium. I have already denoted this epsilon naught m. So the force, as two charges are placed, 2 point charges are placed in some medium. So force will be there according to the Coulomb's law, and the magnitude of that force we can calculate with the formula. We have formula now. I am representing this force between two charges F m, F suffix m. And why I am taking the direction like this? Because I am supposing these charges are positive charges. You can also take the negative charges,
Okay, sir.
both negative, or either you can take the one positive, one negative. I am just doing. So the value of the force will be 1/4 pi epsilon m, and the product of two charges, that is Q1 and Q2, and divided by the square of distance. This is the equation 1. This is the equation 1. Now I am taking this same system Vacuum is also known as free space. A space free from everything. So this time here two charges are placed and air is in between these charges, and for air we have the permittivity of air as epsilon naught. We have the permittivity, and this time the force will be different because we have changed the medium, so force will be different.
Yes, sir.
Because the force depending upon the medium, distance is same, the magnitude of both the charges remain same, but this time we have changed the medium to
The
air.
medium is reduced.
So
Yes.
that is why the value of force will change, and I am representing this force with epsilon 0, or you can say epsilon naught, epsilon 0 and epsilon naught. And this epsilon 0 is 1 upon 4 pi epsilon 0 or not, product of charges divided by r square,
Hmm.
and this is the equation 2. So now divide this the equation second with respect to first. You can divide just writing like this, second divided by 1. So you will get this value when you will divide the equation second. So this is the LHS, left hand side of the equation,
Yes, sir.
and left hand side of this equation is f suffix m, and you can divide it now. 1 upon 4 pi epsilon 0 q1 q2 divided by r square, and here we will get 1 upon 4 pi epsilon m q1 q2 divided by r square, and now now this 1 4 pi gone,
Yes, sir.
this is also gone,
Yes.
this also gone, this also gone, this also gone. Now we have f naught divided by fm. We have 1 upon, here we have only 1 upon epsilon naught, and
Yes, sir.
in the division of that we have 1 upon epsilon m, and when you will solve this, this will become 1 upon epsilon 0, and this is 1 upon epsilon. When this will come in the multiplication, this term will be here, and here is 1.
Okay,
So we
sir.
will get f naught divided by fn and epsilon m divided by epsilon naught, and this value is the dielectric constant. So this is just the I want to drive. So I want to tell you that the conclusion for derivation, or the purpose of this derivation, is to make you understand that this is just you can compare the value of forces with respect to k. If you know the value of k, then you can find how much times the force in air will be greater than the force in the medium. Okay.
Okay.
So if now see here, very interesting thing is here. I am just taking this equation. Dielectric constant is equal to force in air and force in medium. If I want to find force in medium, then I will write force in air divided by k. So if k is given to you, you can find easily the value of force in medium. If k of the medium is given, then we can easily find the force in medium. We will not
Yes.
apply that formula 1 upon 4 pi epsilon naught. We throw, this is the thing, And here I am just denoting all the units, all the things. K is the dielectric constant of medium. Dielectric constant of medium. Like medium, water have dielectric constant 80, air has dielectric constant 1, metal has dielectric constant infinite, means there are certain values of the medium, okay? And
Okay, sir.
yeah. And epsilon m is the permittivity, or you can say absolute permittivity of medium. Permittivity of medium. And epsilon 0 is the absolute permittivity of air, or free space is also known as vacuum. So you can write free space for either vacuum,
Okay, sir.
free space or vacuum. And F suffix 0 is the force in air between the 2 point charges. Force in air. And F suffix m is the force in some medium. Medium of dielectric constant K. Constant K. If the medium is there, then there is always the value of a constant dielectric constant of that. You will get in the question also.
Okay, sir.
Yeah. And I have derived this result, and from here I can derive one more result. So see here, we have K is equal to epsilon m divided by epsilon naught. If we want to find the absolute permittivity of medium, and if we know the value of dielectric constant, then we can easily find this, because we know the value of epsilon naught already. I have told you epsilon
Yes,
naught
sir.
is 8.85 into 10 to the power minus 12. So this we can also do. And okay, write this down, and after that we will solve the question on this. Are you making notes of this?
So yes, sir.
Okay, fine. Please note it down, and after that we will solve a question on this. Then you will be understanding the concept in a better way.
Okay, sir. So can you scroll down? So can you scroll?
Okay. So, just I want to tell you the significance of permittivity. Significance of permittivity. Written?
Yes, sir.
Okay, fine. Just I am telling you. So, see here we have the force 1 upon 4 by epsilon. If the body is if the charges are placed in medium, we have this q1, q2 divided by r square. See here, this force, we are getting the force by dividing this thing,
Yes, sir.
epsilon m. And epsilon m is the, we know dielectric constant is equal to epsilon m divided by epsilon 0.
So
And
from log.
you will see, I am just telling, k is generally greater than 1. K is generally greater than 1. So you can say that epsilon m uh, is greater than 1.
Okay.
And you can see here, when you will divide something which is greater than 1, which will reduce this thing, this force. Means suppose I am saying 5 is divided by 0.5, then it will become 10. 5 is divided by 0.5, it will become 10. But when you will divide 5 with 2, it will become 2.5. See here, when you are dividing a number with a number greater than 1, the overall value is decreasing here. Overall value is decreasing.
Sir.
In the same way, the force will decrease due to this permittivity. So, in simple words, permittivity of a medium, you can think permittivity of a medium is something, you can say, the property of a medium which reduces the force of interaction in between two charges. Okay.
Okay.
Okay. This is just okay. So now we will solve one question. So question is, two charges, or you simply say 2 point charges. If in the question it is written that two charges, you will take always point charges,
Okay, sir.
q1 and q2. When placed at a separation, when placed at a separation, when placed at a separation, R, or you can now this time take D, place a separation D in air, repel each other, with force capital F, with force capital F. Now, this is for a stop at what separation? At what separation? They means 2 point charges. At
Point
what
charges.
separation? They must be placed in a medium in a medium of dielectric constant 3. So that same force of repulsion is there in between two charges. Now this is the question. So for solving any numerical in this chapter or in the other chapter, so you should, the most important thing is to read the numerical very in a better way, okay? Very carefully.
Okay, sir.
Relate all the points. Like see here, they are saying 2-point charges Q1 and Q2 when placed at a separation D in air repel each other with a force F. So I am taking 2-point charges Q1 and Q2, and I have placed these point charges with a separation D given in question, and they are repelling. Repelling means the force is in this direction and the force is in this direction, and the value of the force is given to us.
Okay,
Now
sir.
that why I am taking the direction of the force in this direction, because I have told you the force of attraction or repulsion will be along the line joining the two charges. This force cannot be like this,
Yes, sir.
because this is the force between 2-point charge according to the Coulomb's law. So they are saying earlier the charges are air. Earlier the charges are placed in air.
Yes.
These charges now placed in air. So what we will do, we will just calculate the value of F. We know for air we use 1/4 pi epsilon 0. I have told you we will use this when we will take air.
Yes, sir.
Q1 Q2 divided by D square.
B square.
So this is the equation 1. Now they are saying at what separation they must be placed in another medium. They must be placed in another medium of dielectric constant 3. So that same force of repulsion is there in between two charges. So now they are saying place these two charges in some medium, and dielectric constant is given to us is K is given to us as 3, and now we will put these charges in some other medium, but we don't know this time the distance between the two charges. We have to find that distance. So I am just placing the two charges in some medium, and I am just supposing that they are just placed in some medium with some distance. I am just considering D2. You can consider K also, you can consider whatever you want. And
Okay.
same system is placed. And again they are saying, again they are repelling with some force
F.
F.
Yes.
Again they are repelling with some force F. We have to find the value of this D2. So now this time this system is placed in some medium, and for the medium we have the formula. When we place some charges in medium, 1/4 pi epsilon m product of two charges divided by distance square. Distance this time is D2 square.
D2 square. Yes.
Yeah. Okay, fine. And we have Fm is F.
Yes, sir.
Yeah. but we do not have epsilon m. We do not have epsilon m. So see here, I have told you dielectric constant is equal to epsilon m divided by epsilon naught.
Yes, sir.
From here, I can find epsilon m, cross multiply. Do you know this? Can you find this now? Epsilon naught will be k times of this.
Yes, sir.
So instead of epsilon m, I can write k epsilon 0.
Yes, sir.
Very good. And q1, q2 divided by d2 square. d2 square. This is equation number 2. Sorry. But we know that this force is equal to this force.
Yes, sir.
This force, both the forces are equal. So we can write equation 1 is equal to equation 2.
2.
So equation 1 is this 1 upon 4 pi epsilon naught given q2 means force will be equal to force now.
Yes,
This
sir.
force, yeah. You will write first force, this force in air, this force in some medium.
Medium. Yes, sir.
Medium of k is equal to 3, and you will place all the values 1 upon 4 pi epsilon naught q1 q2 divided by d square. q1 q2 divided by d square, and this is 1 upon 4 pi k epsilon naught q1 q2 divided by
D2 square.
d2 square. d2 square. Now cancellation process. 4 pi is gone. q1 q2 gone,
Yes, sir.
and epsilon also gone.
Yes.
Here we have 1 by d square. Here
1 by
we
3.
have 1 divided by k into d2 square,
Yes, sir.
and we know k is given as 3.
3. Yes.
So this will become 3 d2 square, and we want to find the value of d2. So we can
Yes,
write
sir.
this as 3 d2 square is equal to d square, and this I can write this d square
D
divided
square.
by 3, and when you will solve taking the under root on both sides, you will get d2 divided
Yes, sir.
by d divided by under root 3. So this is the distance this time. See, under root, the value of under root is 1.7, and which is greater than 1.
Greater than
1 greater than 1 means d2, you can say d2 is less than d. So when you are placing, we got the answer, this is the answer, no problem. You can write in the exam, this is the answer, and you will get full marks. I am just telling this additionally. See here, the distance d2, this distance d2 is less as compared to this. So you can consider, you can conclude from here, when you will place the charges from air to any other medium, either the force will reduce or you have to reduce the distance to make the force same. Okay.
Okay, sir.
Okay, you can now copy this. Sorry.
So again, scroll down.
Written, Ziyad?
Yes, sir.
Okay. So I want to ask you, do you know the vector? What is vector and vector addition and all that? Do you have the idea of that?
No, sir, I'm having doubt on that.
So we will study the vector addition in superposition principle. Superposition principle is nothing but the vector addition of the forces. Here we have two charges. In the superposition principle, we have multiple charges, and we have to calculate the force on one charges. And what we will do there, we will add them vectorically. Add them means all the forces vectorically, and we will get the result. So for that, we should know the vectors. Simple means you can say there is a chapter of basics of vector in the 11th class, but we have to know just the little bit of vector.
Yes.
How to add the vectors when two vectors are at some angle. There are the different addition, like we cannot add the vectors like scalars. We have to see the directions also. Like charge is a scalar quantity. So if I am saying to you, uh, this is the wire and charge here is 5 coulomb charge is there, and okay, and this is another wire here, a 3 coulomb charge is coming in this direction, and you can add this charge in this direction 8 coulomb. If the angle between the charges means this is 120 degree, if the angle is 120 degree, then also the result will same. If you will decrease the angle between the direction of charge, means 5 coulomb charge, 3 coulomb charge and 8 coulomb charge, the result will remain same. But this is not true in case of vectors like forces. If you, we have to follow to add some laws for the for addition of forces or vectors. So superposition principle. Superposition principle. So superposition principle, I am explaining it with the help of one example. Suppose here is a charge placed. Here is a point charge placed, and we have charges. Here is a Q1 charge. Here is a another Q2 point charge, and all the charges we are taking the point charges. Here Q3 charge, and accordingly you have n number of charges placed at different locations.
Okay, sir.
Yeah. And suppose the magnitude of charge placed here is Q0 and Q1 charge is placed here, Q2 charge is placed here, Q3 is here, and so if we want, we know that there will be the interaction of force in between this charge and this charge because both are point charges.
Yes,
There,
sir.
there will be also a force of interaction in between this charge and this charge. There will be also a force of interaction in this and this, and there will be some different direction also.
Yes, sir.
So from this to this, the direction of force will be in this direction due to this charge, and I am supposing this charge is as positive and this charge as positive. You can take any other direction also, no problem. But
Okay,
just
sir.
for the simplicity, I am taking this positive charge. So
Okay.
we know that due to this charge, the force on this charge will be in this direction because due to this charge will be repelled. This charge will try to repel this charge in
Yes,
this
sir.
direction, and the direction I have already told you is in the direction of line joining the two charges. Okay, fine. So I am supposing this as force F1 means force on charge Q0 due to charge Q1 F1. So
Okay, sir.
similarly, I can calculate this force also. Suppose this is a force F2,
Yes, sir.
means due to this charge, the force on this charge, and direction is also given in this direction, This is F2. And similarly, you can draw for charge Q3 similarly. And if you want to draw for fourth charge, you can also draw for that. No problem.
Okay, sir.
And we know that force is a vector quantity, so we write vector like this.
Okay, sir.
Force vector, F1 vector, F2 vector, F3 vector. And see the direction of all the forces is in different directions, and magnitude can also be different. If you will take this distance as R1, R2, R3, and there will be a force due to this charge also, Qn charge.
Yes, sir.
You can also draw this, no problem. This is charge and the force will be like this due to this Qn charge. And this force I am representing F suffix n, and this is a vector on this. So now what you will do, then you will, if you will calculate the net force on this charge Q naught, net force on this charge Q naught, net force on this charge Q naught, then you will take the vector summation of all the forces on this charge, on vector summation of all the forces on this charge. For an example, if I am saying here is a body, this is a body, and a force is acting in this direction F1, and a force is acting F2, a force is acting in this direction on this body F3, a force is acting in this direction F4. So if I want to find the net force on the body, suppose this is a body A, I want to find the net force on the body. What I will do, I will simply write this vector addition F1 F2
Okay, sir.
plus F3 plus F4. This is the net force on the. Similarly, you will do this for charge Q naught. You will write net force FNET, net force on charge Q naught is equal to force due to charge 1 and the vector addition of force due to charge 2 and the
Yes,
vector
sir.
addition of force due to charge 3, and there are n number of charges, so you will add all the charges like F4, in the last we have F suffix n. So this is the superposition principle.
Okay, sir.
And I'm just writing one statement for this. Superposition principle for a system of, if someone is asking what is superposition principle, you can write this definition. For a system of n interacting, small n, this is small n interacting, small n interacting point charges, net force on a charge on a given charge. Here the given charge is Q naught. Given charge is the vectors sum of forces due to individual charge, due to individual charge. This is the statement. This is the given charge, and we have to find the value of forces due to all the charges placed here. Please note it down.
Okay, sir.
This is just the vector addition of forces. We should have just the basic understanding of vectors. When we will solve question, you will get into it. The meaning of f net this f and 80 net q naught is the net force on charge q naught. And one thing more I want to tell you, they are saying for a system. What is a system? System is the combination of two, at least there should be two interacting charges. At least there should be two interacting charges, then it will become a system. If we have only one charge, we cannot say that as that charge a system. We can only
Yes, sir.
say a system when we have two charges and that are interacting with each other. If there is no interaction between the charges, then no, we cannot say the system is. The system is the in system, at least there are two charges and those charges are interacting with any type of force: gravitational force, electric force, nuclear force, magnetic force. This system. If I am saying that here is a plus q charge is placed, this plus q charge will not be called as system. And if I am saying here a minus q charge is placed, then this whole thing will become system. Because why this will become system? Because there will be the force of attraction, means there will be a force. That is why this will become system.
Yes, sir.
Have you heard the word system before?
Yes, sir.
Where? In thermodynamics 11th class.
Yes, sir, I did.
There also we have open system, closed system in 11th class.
Yes, sir. So can you scroll down?
Yeah. Now we will have just a short discussion on the vector. Short discussion. But I completed.
Yes, sir.
Okay. So now we will see. I will take your 5 more minutes.
Okay, sir.
Yeah. Okay. Now, do you know? Can you tell me what is vector? I am just not asking that to judge you. I want to know how much you know about the vector, so that I have to teach you like that. What is vector and scalar? Having any idea about that? Like vectors are the quantities having direction and magnitude, and scalars have only magnitude. Okay, no problem.
Yes, sir.
I am telling. We have two types of physical quantities in our syllabus: scalars and vectors. Scalar quantities and vector quantities. Scalar quantities. Scalar quantities. Example. If I am giving you the example, if I want to give you the example is charge. Charge is scalar. Speed, distance, work, energy, potential. There are many scalar quantities. Scalar quantity is the quantity having only magnitude. These are the quantities having only magnitude. When write, these are the quantities. Quantities is like charge, speed. These all are quantities.
Yes, sir.
Quantities means which can be measurable.
Yes, sir.
Measurable quantities. These are quantities which have only magnitude. Magnitude means the value. Magnitude. Like you can say charge have only value. Charge have only value. Like 2 coulomb charge, 3 coulomb charge, 4 coulomb charge, 5 coulomb charge, 6 coulomb charge. Speed
Yes, sir.
2 meter per second is speed, 5 meter per second is speed, 6 meter per second. Distance 4 kilometer distance, 6 kilometer distance, 5 joule
Yes.
of work, 3 joule of work. Energy is also potential, 3 volt potential, 5 volt potential. There is no
Yes, sir.
need of direction in that. Quantities which have magnitude. Like charge of 5 coulomb. So 5 is magnitude here. 5 is magnitude. 5, what is 5? 5 is magnitude. 5 is magnitude. These are the scalar quantities. Now we will have vector quantities. Vector quantities. So vector quantities example you will take force, velocity, displacement, acceleration. If we will talking about this chapter, we will have the vector electric field. We will discuss this later. Electric flux, or not electric flux is a scalar. Force we have discussed, electric force, electric field, and you can say momentum. And later we will discuss the current density. No need to learn these things. I'm just giving the idea. So for the vector
Okay.
quantities, you see here why the vectors have the direction. See here. If this is a body, this is some block, and I am applying a force of 5 Newton. 5 Newton is the magnitude. 5 is magnitude here.
Yes, sir.
And see here, there is a particular direction of this force now. I can apply this force like this also.
Yes, sir.
This 5 Newton force I can apply like this also. I can also apply 5 Newton like this also. I
Yes.
can apply this 5 Newton force like this also. So there is a involvement of direction here. So for the vector quantities, you can say this is the definition. Having magnitude, having direction, following the laws of vector. If they are vector, they have to follow the laws of vector. As we are human, we have to follow the laws of human. See here. Just give me 2 or 3 more minutes. This is east, west. If this is north, this is south. And
Yes, sir.
I am applying a force in this direction. Force of 5 Newton in this direction. So for the force, so you can say this Newton. Newton is the name of the scientist. N is Newton.
Yes, sir.
Newton is the name of the scientist, and the unit of force is also Newton. So
Yes,
I
sir.
will say 5 Newton force in which direction? East direction.
Yes, sir.
So 5 Newton is 5 is here magnitude of force,
Yes, sir.
and east is the direction. So in
Yes.
this way, okay, note it down. Zooming it out. Now you can note it down. Have you completed this?
Yes, sir.
Okay. Now you can note it down.
Right.
Note this. This remember, please remember, these vectors are very, very important
Okay,
for
sir.
the next lectures.
Okay, sir.
We will discuss more in the next class about the vectors.
Okay, sir.
Ziyad, from where you are?
Pakistan, sir.
You are a student of CBSE.
Yes, sir.
Okay. No problem. All concepts are same in this world. So scalar quantities have only the magnitude, and vector quantities have the magnitude and direction.
Yes, sir.
In the next class, we will discuss more about the vectors. In 20, I will discuss about it 20 to 25 minutes, and